Now I got a message for all you liberals out there. You want my gun, my firearm? Come take it from me. Just walk through my door, come into my home, and take it from me. With your weak, soft, liberal, girlish hands. Just try to put those hands on me. Those soft, liberal hands. Put them on me, on my body. Just slowly, gently dragging your fingers up and down my arm, giving me goosebumps. You want my gun? Come kiss me for it. But not like right away. Don't be too obvious with it. Let's do that thing where our faces get close to each other. And you know what's going to happen. It's just a matter of time. You just stare at each other's lips. But you're waiting for the right signal to give yourself over to them completely. Like in a walk to remember. Come do that for my gun. Bite my lip and play with my hair. For my firearm. If you want my gun, come spank me for it. Not like too hard, but like still hard, you know? Like hurt me but make me feel safe at the same time. You pussy liberals.
So this is my crib for the night where I'm staying. But you want to see something more magical? First, I've got to change into something more adventurous. Come on, follow me. That's better. His boots are so fast.
Alright, so this dude's coming at you with a machete, right?
This is a strip of self-healing polymer. That means I can slice it into two pieces and then with the application of gentle pressure, push the two pieces together and it will become once again one single piece. At first you might think, well, that's not so unusual. Like if I took a strip of blue tack and sliced that into two pieces and then pressed those two pieces together, I would once again have a single piece of blue tack. You might also say, look, if I have two droplets of water and I push them together, they become a single droplet of water. The difference between blue tack and this self-healing polymer is that, well, blue tack is sticky. It sticks to my hand, it sticks to a wall, it sticks to the back of this picture of Patrick Stewart. So it's not surprising that blue tack sticks to itself. But this polymer isn't sticky. The same goes for droplets of water. They're sticky and they flow because they're a liquid. So we should naturally expect different behavior from droplets of water as we do from a strip of polymer. We can actually flip this question on its head. Instead of saying, why is this polymer self-healing? We can say, why aren't other things self-healing? Why isn't metal self-healing? Like, if I cut this piece of metal in two, why is it that I can't just push the two ends together and it fuses back into a single piece of metal? Like, if you think about what's happening at the molecular level, a metal is a lattice of ions in a cloud of mobile electrons. So if you slice this lattice in two and bring those two ends back together, well, to me, that looks like a single metal lattice. So why doesn't it become one? In the case of metal, the answer is actually quite straightforward. It's oxidation. I've got some sodium metal here, which is soft enough to cut with a knife. And when I do, you can see it's actually a really shiny metal, but that doesn't last forever. It doesn't take long for that shiny surface to become dull in appearance. That's because the metal is reacting with oxygen in the air. Actually, the same thing happens when you cut any metal. It's just that that oxidation layer isn't as visible in the case of, say, steel as compared to sodium. So it's understandable then that if you took two pieces of metal and pushed them together, they wouldn't form one single piece of metal because there is a layer of oxidized metal in between. In fact, if you were to cut a piece of metal in the vacuum of space and then push those cut surfaces together, they would fuse together. We know this because it's happened in situations when we don't want it to happen at least once. In April 1991, the Galileo spacecraft was supposed to open its high-gain antenna. Looks a bit like an umbrella, but 3 ribs of that umbrella had cold welded to the body of the spacecraft. and so it couldn't open. This stuff is a bit different to a metal though, because it's a polymer, so it would be more like if I cut a piece of plastic into two pieces and then try to push those two pieces together. In this case, clearly they don't fuse back together. And I suppose that makes sense. Like if you're cutting a piece of plastic in two, then you're cutting through individual polymer chains. You're breaking bonds between carbon atoms. When you break a covalent bond like this, you're left with radicals. That's atoms that have unpaired valence electrons. They're incredibly reactive, so we should expect the exposed surface atoms to react with molecules in the atmosphere, or if it was in a vacuum, I imagine they would react with the atoms around them in the substance itself. And so that exposed surface becomes unreactive. It's not sticky anymore. If you press those two surfaces together, those bonds aren't going to reform unless you can introduce quite a high activation energy. So why is it then that I can cut this material into two pieces, push the two pieces together, and it reforms into a single piece? Well, the full explanation, it seems, is hidden behind trade secrets.
The best paper airplane throw in history.
Oxe, cadê o cabelo do Jonathan?
As we saw Jesse pulling Chucky out, it was just such a special moment. I was just so proud. In total, Chucky was in the water just over 34 minutes.
If I really claim you.
Hey, are you registered to vote? There's a primary on August 23rd and the general election November 8th.